M6C1 test capacitors, question 13, which reads, the diagram below shows a cell of an EMF 9.0 volts, a discharged 580 microfarad capacitor, and two 40 kilo ohm resistors. So there's the battery with the EMF of 9 volts. Here are the two 40 kilo ohm resistors, and this capacitor is 580 microfarads. At a time t equals 0, the switch is moved to position number 1. So this switch is flicked to the left, and the capacitor begins charging through one of the resistors. So just that one. This resistor is not going to be included in the charging circuit. At time t equals 30, the switch is moved to position 2, and the capacitor begins discharging through both resistors. So both resistors will be included in the discharging circuit. Calculate the current recorded on the ammeter at time t equals 15 seconds. So if I just trim that question up so we're just left with a bit at the end, calculate the current recorded on the ammeter at t equals 15 seconds, add to the diagram some of the details like the EMF of the battery, the two resistors and the capacitance, and maybe a little line just to show that the switch is currently set to position number 1. In order to calculate this, we're going to need the initial current flowing in the charging circuit, and that's just going to be as simple as V equals IR, rearranged to make either subject, V divided by R. That's literally going to be the I0, so that'll be 9 divided by 40 kilo ohms, and that will be the initial current flowing when we start charging the capacitor at time t equals 0. This initial current will then become the I0 in our decay equation for current in charging the capacitor here. A lot of people think that that is the discharging version and this would be the charging version, and that's broadly speaking true for potential difference and for charge, but for current is always decaying. So this is always the equation that you would use for current, regardless of whether it's charging or discharging. So we've got a value for I0, the initial current flowing. That current is going to decay over time. The only thing that we need to do now is add the 15 seconds for our time. The resistance is going to be 40 kilo ohms because that's the only resistor contributing to the charging circuit, and the capacitor is going to be 580 microfarads. Bung that into a calculator. Don't forget to put kilo ohms times 10 to the 3. Don't forget microfarads times 10 to the minus 6.